Hi everyone, this is a short video to present a question about flux density and divergence theorem.
The question that assigned to our group is a 50-meter long coaxial cable consists of a line conductor that is surrounded by a cylindrical structure of B minus A millimeter thickness as in figure Q.1. Line charge density ρL coulomb per meter exists along the line conductor while the cylindrical structure has a volume charge density of ρV coulomb per meter cube. In this question, it is divided into three parts. For the first part, we have to find the electric flux at the length of radius is between A and B. For the second part, we have to determine the value of ρV inside the cable when the electric flux is 0 at R greater than B. And the ρL value given is equal to 0.9 pi picocoulomb per meter, and A is equal to 20 mm and B is equal to 30 mm. For the last part, the question gives that A is equal to 20 mm and the value of ρL is equal to 0.9 pi picocoulomb per meter. We have to find the electric flux at R smaller than A due to a segment of the line conductor with a length of 50 mm.
In this question, we have to apply Gauss' law, where the integration of d ds is equal to q enclosed. The integration of d ds is equal to dr times 2 pi rl, and it is equal to vector d over unit vector r times 2 pi rl. And for the q enclosed, it is equal to the integration of ρl dl with the upper limit of L and lower limit of 0 plus ρv times the integration of r dr with the upper limit of R and lower limit of A times integration of dv with the upper limit of 2 pi and lower limit of 0 times the integration of dl with the upper limit of L and lower limit of 0. And it is equal to ρL times L plus ρv times pi times the bracket of R squared minus A squared times L. And we know that the vector d is equal to epsilon naught times vector e, and we substitute the equation into the integration of d ds equal to vector d over unit vector r times 2 pi rl. So we can say that the integration of d ds is equal to epsilon naught vector e over unit vector r times 2 pi rl, and q enclosed is equal to ρL times L plus ρv times pi times the bracket of R squared minus A squared times L. And after we simplify it, we can find that the electric flux is equal to ρL plus ρv times pi times the bracket of R squared minus A squared over 2 pi epsilon naught R. And the direction of the electric flux is same to the direction of R. And the unit for the electric flux is equal to voltage over meter.
Next, for question 2, to determine the value of ρV inside the cable when E is 0, given that R is greater than B, and we will use the previous equation of electric field intensity and let it equals to 0. At the same time, we will sub R with B, and we will get that ρV equals to negative ρL over pi times with B squared minus A squared. And then we just sub in the value of ρL equals to 0.9 pi picocoulomb per meter, A equals to 0.02 meter, B equals to 0.03 meter, and finally we will get that ρV equals to negative 1.8 times 10 to the power of negative 9 coulomb per meter cube.
So now I will continue to explain part 3. From the question, we know that the value of A, the density charge ρL, and also the length of the line conductor. And hence we can draw out this diagram. And the R is smaller than A and which is perpendicular to the line conductor. Then, to find the electric field due to the straight line charge of finite length, we can use this formula. So now we need to find the sine alpha 2 and also sine alpha 1. As we know, we can use trigonometry formula to find sine theta, which is equals to the opposite divided by the hypotenuse. From the diagram, we can see that at angle alpha 2, the opposite is equals to x minus z. And the hypotenuse, we can use the triangle to find it, which is equals to square root r squared plus x minus z squared. Then we substitute it into the equation. And then for this part, we assume it as 0 since the direction of z is parallel to the direction of line charge. And hence there is no electric field, because the direction of electric field must be perpendicular to the line charge. And after that, we can see here that the value of 0.025, which is equals to z minus y and also x minus z. We assume z is at the middle of the line, so we just divide the length into 2 and we will get 0.025. And then after we calculate it, we will get this answer.
That's all from us. Thank you for watching the video.